Hello, programming languages students. As we jump into this Prolog module, I kind of wanted to jump ahead a little bit and show you guys, maybe motivate you, about the usefulness of Prolog. Basically, any puzzle you encounter that is a logic-based puzzle or has a series of rules that you have to follow to find answers, anything with restrictions, Prolog is incredible for. And it's also great for AI. So I'm not going to dive into the AI examples because it gets a little bit tricky to show you that. But I can show you a couple of really quick things that Prolog is great at. And we'll talk about what the program actually looks like and how it's written. But I just really lightly want to cover what works here. So to start, let's say that um, we want to solve crossword puzzles. Prolog's great at this. And so let's say we have a word bank and we want them to fit into a grid. And so the important part is we have overlapping letters here, right? And so what are all the possible ways that you can fit abalone, abandon, anagram, connect, elegance, and enhance into this grid? This is solvable, and even in procedural languages you could solve it, like Java or Python. So if you'd like, pause the video, take a few minutes to come up with at least a plan. I don't want you to write code, but at least a plan for solving this. What would the code need to look like? What would need to be written? Maybe you loop through all these words and you track which letters go where and make sure that the letters for any other words that go the other direction match. There's ways to do this, but let me pause for a second here. Let you pause the video and just think about how complicated this program would be. Okay, so hopefully if you dive in and if you really think about this, the difficulty, the idea of finding individual letters within the word and then figuring out all the combinations of the letters that match, it's a daunting task for any procedural language, Java, Python, whatever. Well, let me scroll down and show you the Prolog solution. This is it. So we define our word bank with the word and then each of its letters separately. So this isn't too hard to do. And then we just define what our crossword puzzle looks like, right? So we have enhance. It would define this as a word. Enhance has E-N-H-A-N-C-E, right? So just the word and its letters. And then Prolog could also give us a crossword puzzle. And so this crossword puzzle has 3 horizontal words and 3 vertical words. Um, Horizontally, we have A, B, and C here. And you'll note that as we cross compare these things, horizontal 1, we don't care, don't care, don't care, don't care about 4 of the letters, and about 3 of them we do, right? So it's the same representation here. So for horizontal 1, we don't care, and then we have a variable A, don't care, have a variable B, don't care, have a variable C, don't care, right? So that's basically building this pattern. All right, so the logic here hopefully makes some sense. Then the corresponding vertical word V1 is going to have an I don't care what the letter is, and then an A. And note that these two variable names match. If you look at all the combinations about the horizontal words and the vertical words here, you'll see that basically what we built is an alphabet where this is variable A, this is variable B, this is variable C, this is D, this is E, this is F, G, H, and I. And so by defining H3 with these letters and H2 with these letters and H1 and V1, V2, V3, just the logic of the crossword puzzle is built into this. So what does it look like? Well, you'll see a little bit more of this as we go along, but we define this as our Prolog program. And then we say crossword with some variables. What's H1, H2, H3? What are V1, V2, and V3? And if you run it, it'll just tell you straight up which words would fit in H1, H2, and H3, and V1, V2, and V3. And it'll not only show you one solution, it'll show you all possible solutions. So note that you could flip things. Horizontal 1, 2, and 3 could become vertical 1, 2, and 3, and vice versa. And so you can find both of the possible solutions to this problem. And so more than understanding what this code is truly doing, what I hope you're seeing is just the logic, right? We build the logic about what the crossword puzzle looks like using variables for crossing points. And we have the logic for what a word looks like. And just from those logical tools, Prolog is capable of solving the problem. So it's pretty neat. The other thing I wanted to show you is that if we look at a Sudoku example, things get a little more complicated. And by the way, credit to this metalevel.at/Sudoku. This is where I got a lot of the programming from because this is tricky to write, but I just wanted to cite it real quick. Um, but what we get out of this, so if I make use of the code that's written here, we define some definitions for what Sudoku is. If you're not aware, it's like a 9 by 9 grid game um, where you can't match the same number in the same row or the same column or in the same 3 by 3 square, and so the board's kind of broken up into squares. Um, and so this is an example of a Sudoku game that I'm just going to pass into this. And so this is a really short, just a few lines of code, Sudoku solver in Prolog. And I'm giving it a problem. And so if you take this code, and I can give it to you if you'd like. I think it's available on Moodle, or if you go to that site, that metalevel.at/Sudoku, and you get pieces of this code and combine it with what you see here. Um, what you would be able to do and test is run any Sudoku you want in here, and then just run a command. The command at the bottom I'm going to cut out and paste here. You run a command to solve problem 1 and get all the rows from it. So let's clear this out and let's just run this. Well, our Sudoku solver, with only a few lines of code, and maybe even diving into the logic here is a little bit tricky, but without even diving into the logic, I just wanted to show you that with a few lines of code, you can give any Sudoku problem to this program, run this line, and it will solve your Sudoku. Line 1, line 2, line 3, line 4, line 5. So if you ever get stuck, you're like, you're stuck on the Sudoku that you're working on and you can't figure out a solution. Well, if you need a solution, plug it in here. You got the solution. So all the blank spaces are underscores and just type the numbers where they are. Prolog is very powerful. With just a few lines of code, it can solve some very, very complex logic problems for any kind of Sudoku or any sort of logic-based problem. So hopefully this is exciting. This shows you what Prolog's capable of, and maybe it'll help you be a little more motivated to learn it. Thanks, everybody.